Hello and welcome back to the key for the homework 4.1. Alright, so we're given the factor by which each pre-image was multiplied to create the image. Use the scale factor to find any missing lengths. Here's our formula. The image lengths divided by the pre-image lengths is the scale factor. So we ended up here at 2. We divide by 1. 2 divided by 1 equals 2. There's no missing sides there. Let's do the difficult thing. 4.5. This is the image. Divide by where we came from, 1.5. Turns out to be 3. We could have also done 6 divided by 2, which is also 3. So the scale factor is 3. And now let's find some missing sides. This side corresponds with this side. 1 times 3 is 3. This side corresponds with this side. 1 times 3 is 3. And z corresponds with 1.5, which times 3 is 4.5. Muy bien. Okay, now this is the image. 2 divided by 8. 2 divided by 8 is 1/4. It got smaller. It shrinked it down times 1/4 portion. The Force Awakens reference. All right, so 2. Ooh. Okay, now this is interesting. Whatever is sitting here becomes 2.5. So we can actually use algebra for this. A times the scale factor ends up being 2.5. Divide by 1/4. Okay, so you got to know this to do algebra. Dividing by 1/4 is the same as multiplying by 4 over 1. If you think about it, yeah, multiplying by 4 over 1 would simplify this to be 1s, and the 1s are 1s, and these are all 1s, and everything's a 1, and 1 times a is a. So we solved for a. A is by itself now, yay. But what about this side? We forgot to multiply by 4 over 1. And 2.5 times 4, so multiply dot, let's see, is 10. Over 1, because 1 times 1 is 1. Okay, great. So we figured out a is 10. Two times 1/4 to get to that corresponding side is 0.5, or 1/2, or 50/100ths. Okay, number 4. I want to pause for a second just to say I apologize for the last video if it didn't upload in time. I tried to film in 60 FPS, frames per second, and YouTube did not like that. I think the first attempt didn't even process correctly, but anyway. This time I'm going with 30 frames per second, but I'm going with a 3:4 aspect ratio. See what happens here. Now we don't know for sure. 1.5 and E look like they're the same. I bet they probably are, but we don't know for sure. We don't. This could be 1.6. This could be 1.55. Who knows what E is? So let's figure out if we can get a scale factor. Here we go. Take the image and divide by where we came from. 6 divided by 4 equals 1.5. Scale factor is 1.5. Okay. So now we're starting here. 4 times 1.5 is 6. 1.5 times 1.5 is 2.25. So D is 2.25. And that means that these are the same. 2.25 divided by 1.5 is 1.5. Okay. Take where you are, the image, where you end up, divide by where you came from. You gotta look back. What's my scale factor? What scaled me up? That's a good question to ask yourself. What scaled me up to 10? Well, 10 divided by 2 is 5. So 5 scaled me up. That means M is 10. M is 10. And N is 17.5. Hey Google, what is 3.5 times 5? What is 3.5 times 5? What is 3.5 times 5?
3.5 times 5 is 17.5.
That's what I thought. Okay. Alright, this one's fun. This is 4. This is 12. The image is the large triangle. So what scaled us up to this from 4? 12 divided by 4 is 3. So let's do z first. If that's 4 and the whole thing's 12, that's 8. We didn't even need the scale factor to figure that out. We could have done that without knowing the scale factor. Now, at this point, you have to use Pythagoras. This is missing. And also this little one, or we could also just go with parallel lines. Let's do that. Now we know that that's also a 90. Okay. Now, I don't know why they forgot to do that. Maybe it's just so that students could go to their teacher and say, hey, they didn't actually put the 90 in the corner. True. Very good. This is good to know. We are experts now. This little guy, though, is a famous triangle, 3, 4, 5. 3 squared plus 4 squared equals 25. Square root of 25 is 5. So x is 5. Why did no one correct me when I put that in the wrong spot earlier? Now we can scale it up. Y is 15. And they didn't ask for this, but we're experts, so let's go get them. Let's call this R. And R equals 10. Pretty sure. Yeah, x is 5 plus 10 equals 15. Yeah, I can math it. Yep. Actually, you know what? For that matter, I did not see this 9 there. Does that change anything? No, it does not. No, don't think so. I think you still need Pythagoras. Okay, whatever. Oh, the fun part. Okay, Fran walks backwards to a distance that will allow her family to all show up in the photo she's about to take. I drew this little picture. They don't fit. The people don't fit. Now the people do fit. They shrank down. So scale factor smaller than 1. Remember, it always points to the small one. Small end of the symbol, small thing. So the SF, the scale factor, is smaller compared to the big one, 1. So, but also the scale factor is bigger than 0 because it didn't shrink down to a dot or turn upside down and go back, go negative. So some fraction. And the center of dilation, COD, is the center of the frame, assuming she doesn't like repoint the camera also. Speaking of center of frame. The theater technician plays with the zoom in and out in an effort to fill, that's a key word, fill the entire movie screen with the image. And that implies it wasn't full before. That implies the scale factor is greater than 1. Scale factor is the big one. Now 1 is the small one. And again, center of dilation, center of screen, probably. I mean, if you're zooming in and out, then the scale factor is both bigger than 1 and less than 1 as he's going in, whatever. Melanie zooms in on a picture. She has her phone by touching with 2 fingers and spreading them apart until the picture is enlarged to the desired size. So scale factor bigger than 1. It's getting bigger, making things bigger. Zooming in, they get bigger. The center of dilation is betwixt her index and thumb. I'm a index finger and thumb. Let's say that's the only way practical people pinch and zoom. Maybe no one does this, right? No one does index and middle finger. Between your index and thumb, halfway between them, probably. Digital animator creates an artistic work on her computer. She is currently doing an animation that has several telephone poles along a street that goes off into the distance. Let's draw it. Telephone pole. Okay, here's the street. Okay, as telephone poles go off into the distance, things that far away are smaller and smaller. Whoops. Yeah, that's good. Okay, let's find the center of dilation. We follow the lines. Ta-da, where they all connect. Remember, when there's a dilation happening, all lines connecting corresponding points meet at the center of dilation. So the bottom of the poles are all corresponding, and that is the street, and that ends up here. The tops of the poles are all corresponding, and they follow a line, and they meet here. That's the center of dilation. On the horizon, scale factor from 1 to the next is less than 1, smaller than 1, and ultimately it scales down to nothing, to 0. Miss Sunshine is having her class do a project with a rubber band tracing device that uses 3 rubber bands. Okay, so this is the pin corner. Rubber band, rubber band, rubber band. This is probably the pre-image tracer. Don't feel bad if you couldn't do this problem. It's not really clear what the question is. And then this is the image. Now you can imagine if they do a little circle here, this is going to do a big circle here. So the scale factor is greater than 1, and the center of dilation is the pin. Is pin. Who needs complete sentences? Copy machine says blah 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 blah. Scale factor, specifically times 3 this time. We got it. And center of dilation, probably the corner. Again. Whew, we're almost done. 12 minus 7 is 5. 19 minus 2 is 7. Right. Quadratic again, justification, exponent, second power, raising the variable to its second power. Linear, highest variable, exponent 1. And that's the homework. Wait, 4 of 5? There's another page? Oh. Quad, shape, quadratic, output goes to infinity for both large positive and large negative numbers. You know, it's a parabola. I mean a parabola. All right, let's do some math in here. 5 minus 5 is 10. 19 minus 5 is 14. Remember, this was 5 minus negative 5. So taking away 5 negatives, but you're already at positive 5. So when you take away 5 negativities, you actually jump up to 10, positive 10. All right. Oh, no. Oh, double no. Look at this. We forgot to look over here. Trick star. That's not 9. That's 7. That's 11.
Our guest has arrived for today. I'm on my way back up.
What is this? 8. Okay. So here's the thing. We have to find the second differences over here, right? 2, 4 over a span of 2. 8 over a span of 2. I think this is exponentialer. This is very... Let's keep going with the pattern. This next one would be 13, which would take us up to 38. Oh boy. And this, what's the pattern here? 4, 8, pattern's way out here. 4, 8, 12, which would make this 34, which would make this 75. Dang. 12 divided by 2 is 6. 8 divided by 2 is 4. 4 divided by 2. Oh my god. Yeah, this is exponential. It's not settling down. This is settled down. Does this settle down? Oh, you know what? I think it's cubic. We don't even know what those are. Is that even an option? We'll just say it's none of the above. I will get back to you about this. Justification. Thanks for staying to the end. 44 Club, out.